For those who keep an eye on the sky, seeing a meteor is something quite common on any given night without light pollution. Dozens of meteors can be spotted, and the best part? You don't need any special equipment for it. That's what makes it a truly special phenomenon. However, we usually observe meteors from the surface of the Earth. But what if we could see them from above, so to speak? In other words, what would it be like to observe them from space? Well, astronauts and satellites have already captured these rocks streaking across the sky from that perspective. In today's video, we'll explore the rare view of a meteor seen from space. To begin to understand how interesting the dynamics of meteors are, let's keep in mind that such observations are only possible thanks to the atmosphere of our planet. If it didn't exist, not only would life as we know it cease to exist, but the Earth's surface would be incredibly marked by craters. Basically, it's the climatic and geological changes that make the planet's surface devoid of impact signs. But believe it or not, they've occurred aplenty throughout our history. Still, it's not easy to create a crater on the surface, and often the space rock simply disintegrates upon impact with the air. In essence, when we witness the trajectory of a simple meteor in the sky, in just seconds, we could be witnessing a meteoroid traveling at a very high speed. We're talking about something in the range of 50 to 200 times the speed of sound in the atmosphere, which translates into truly impressive numbers ranging from 60,000 to 200,000 kilometers per hour. In this context, this parameter has the potential to reveal fascinating information about the space rock in question. In practice, speed and entry angle are the two main factors here. Speed can indicate the origin of the space rock, and the entry angle can provide an orbit calculation. Some meteors enter the atmosphere at truly gigantic speeds, sometimes exceeding 200,000 kilometers per hour. This already suggests that the rock may not be from the inner solar system because large hyperbolic orbits bring with them great speed, as they are objects coming from great distances from the outer solar system and even beyond. Do you remember the object Oumuamua? It's an example because it represents one of the cases of space rocks with exceptional speeds, once its origin was beyond our solar system. There is strong evidence that it was an object ejected from a distant stellar system to explain its immense speed, estimated at 160,000 kilometers per hour. Asteroids from the inner solar system, depending on how they hit Earth, can have lower speeds, for example. However, speed can be just an indicator, but when a camera manages to make two or more recordings at different distances, triangulation is done, and astronomers can obtain precise orbits of these objects. All these points only prove that the science of meteors is truly fantastic, and among the unexpected phenomena we have in the sky, it's the one that generates the most breathtaking images. If you've been following the mysteries of space for at least some time, you know that we always have meteors streaking across the sky, and they become videos here on the channel. However, there's something in common among these objects: they were all recorded streaking across the sky from the surface. Usually, these cameras are strategically installed to capture as many meteors as possible in the best way possible. They are extremely sensitive, where even the faintest meteor can be recorded. But when we talk about recording meteors in space, the task isn't easy because we're dealing with fewer cameras than we can install here. That's why the number of meteors recorded in space is much smaller, but it exists, and the perspective is fantastic. In some cases, satellites capture a condensation trail left behind in a large event. Let's see the first fantastic recording made on the International Space Station by the camera of the METEOR project, where since 2016, observations of meteors in Earth's orbit have been conducted using an ultrasensitive camera. The project obtains details down to the surface of the Earth while the station traverses the Earth's night, operated by Japanese researchers. The recording of the meteor in question was made while crossing the Geminids meteor shower in 2018. Besides generating such breathtaking images, the perspective provided by the ISS's position at 400 kilometers above the surface allows the meteors to be recorded with extreme clarity, enabling extremely precise spectral analyses. In practice, this can determine the real composition of the rock entering the atmosphere of our planet. The project was concluded in 2019 after obtaining 30 terabytes of data in 3,000 hours of video recording. They used a camera like the one we can see on the screen, and of course, this was not the only recording during the activity period. While crossing the Perseids meteor shower in 2016, the project recorded these rocks streaking across the sky amidst the city lights below. What is particularly striking, especially in the first example of a meteor, is that the camera managed to capture the clarity of the ionization trail of the phenomenon. Extremely high speeds result in rapid heating of the air to temperatures comparable to the surface of the sun, generating exceptional brightness. This phenomenon usually begins between 90 to 100 kilometers altitude when the space rock creates a trail of ionized gas, turning atmospheric gases into plasma, which consequently makes the atmosphere glow. But weather satellites have also recorded such events, as was the case with the Chelyabinsk event in Russia in 2013. This was one of the most well-recorded events in video history. Later, weather monitoring satellites captured the trail being carried by the wind. The sequence of images is simply fantastic. But wait, it's not over yet. In a video compiled with a sequence of images from the Himawari satellite, researchers were able to capture the trail of another meteor as powerful as the energy of 10 atomic bombs. This specific satellite captures an image every 10 minutes, and the time-lapse covers 4 hours of time. The explosion occurred above the Bering Sea and was estimated to be as energetic as 40% of the total energy of the Chelyabinsk event in 2013. The perspectives are truly impressive and complement the vision we can have of these truly amazing phenomena. Unfortunately, satellites cannot capture all the meteors that fall due to the practical resolution of the cameras. Only events of very energetic nature can be sighted at high altitudes in Earth's orbit. Otherwise, we would have many more records like this. Meteors are already fantastic in themselves, imagine seeing them from above. These images we just saw are rare in space records. If you enjoyed this video, don't forget to leave a like, which is very important. And if you're not subscribed to the channel yet, I invite you to hit the subscribe button down below. Until next time.